The geographic bar for living in Cascadia is to know at all times where you are relative to 50 feet, 100 feet. And I intellectually knew about plate tectonics and geography and whatnot in November of 2004, but only after the Sumatra earthquake and Indonesian tsunamis did it really hit me viscerally, like, shit, I live in a place that does that. That happens here. Talk a little bit about what my job is. I work OSU faculty. I work coastwide and coastal natural hazards. What that really means is the North Coast on tsunami education and coastal erosion and shoreline change. So in the 10,000-year record of history, this region, and believe me, we'd feel a magnitude 8 in the southern part off southern Oregon, has experienced some Cascadia event every 250 years for the last 10,000 years. And the last time we had anything was, yes? 600. Good. Yeah, so 312 years ago. So this is great that I'm in a group of geographers here. So this will be ultra embarrassing when you can't answer the following question. If you felt the earthquake right now, it just wouldn't stop. 30 seconds, keeps on going. What would you do? So what's really cool about Seaside is there's all kinds of wonderful north-south streams and wetlands between where we are and where we need to be. And there's like 3 rickety 1972 build bridges that get us across those wetlands, marshes, and creeks. And so, in fact, this is a rather dicey spot, as are all these places around here, to get the hell out of it in the earthquakes. Go to 12th Street and then go up to Sunset Hills. There's actually a neighborhood up there that has barrels in the garage with some supplies for people. They're expecting friends and neighbors to come by. And that's one of the cool things Seaside's done, is place some caches and some stuff up in the residences up in the hills. Because the reality is going to be, during the earthquake, wood frame houses do pretty good because they flex. So duck, cover, and hold, wait for the thing to stop, get out of the building, get to high ground. Stay there overnight. Because tsunamis come in and out. Don't survive an earthquake, survive a tsunami, and then get killed because you went back into the inundation zone. Very embarrassing at the pearly gates when they ask how you died. The weird thing about this is the geology has only been since the late 80s, or call it 1990, that the scientists understood that this subduction zone fault doesn't do what all of the other subduction zone faults on the planet do, which is have big earthquakes and tsunamis. But since white settlement, there hadn't been any earthquakes really at all, and no local tsunamis. And so why? We're on this huge subduction zone. You know the physical geography of this that's going on. Pacific plate subducting under the North American. But with no earthquakes, so the theory was, well, it must be well lubricated and those plates are sliding by each other really smoothly, and so no earthquakes. Well, what they figured out was instead, it's locked up and it's bending like a bow, and there aren't any earthquakes because the tectonic torque is deforming us right where we are. And then every so often it releases, boom, subsides, the whole region drops about 6 and over 20 feet. And then it's fine for another 300-500 years. It's like pushing 2 rugs together. They just kind of, as they scooch, one bill is up and then it releases and then it keeps on going forever and ever. I mean, the Pacific plate is coming this way and subducting at about 40 millimeters per year, which is about as much as your fingernail grows. An adult fingernail grows in a year is how much those plates are growing. And that's not very much until you consider not cutting your fingernails for 312 years. And that's a lot of earth moving around. So that's essentially it. And it's coming at this direction, subducting underneath. The subduction zone, I mean, the westernmost part of it is about 50, 60, 90 miles off coast. But the eastern part is at the bottom of the Cascade Range. And so it's like a burrito. The Pacific plate is underneath the North American plate by a good bit. And my fingernails represent the out in the ocean part that when it flips up causes the tsunami. But my fingers down on this end of it are tickling the molten lava, the magma, underneath the Cascade Range. about Mount Hood and Jefferson and all of those. So the recurrence interval for math freaks is a probability of 1 in 37% chance in the next 50 years of an 8 or a 9. So that's 1 in 3. That's like drawing straws. There's 3 straws, one's short. You pick. It's 15% in the next 50 years for a magnitude 9. So that's like looking at a six-sided dice, 1 through 6. Pick a number and roll it. I mean, these are probabilities that are getting into human perception. Here's another statistic that helps put it in perspective. We're 312 years into the cycle. By this time in the cycle, over this 10,000-year history, 75% of the earthquakes have happened by now. So it's not like we're moving into the time where the earthquakes might start to happen. I mean, we're like, it's third quarter and we haven't had an earthquake yet. A prudent people would act as if they understood that this will happen again. When you see the core sample of 19, it's pretty, you just don't go, well, gee, I bet geologic processes stop because we've moved here. Same thing with shoreline change and things like that. They happen fairly regularly in geologic time. Given historic averages, we're about due. And if you feel a giant earthquake, you can expect a giant tsunami in 15 to 30 minutes. Tsunami is many times more devastating than the earthquake. The earthquake next time will kill hundreds. The tsunami will kill tens of thousands because this whole area is in the inundation zone. It will inundate this. Everything flat that you can see will be inundated. It has been repeatedly in the past. When the earth shakes, all the soil types react differently. And so the harder the soil, the less of a ride you get. The slipperier and sloppier the soil, the worse it turns into jello. Everywhere flat on coastal areas in BC and down here is on-fill material. They're the river mouths. I mean, they're flat for a reason. And so we put our stuff there. The Indians didn't put their stuff there. They put their stuff up on a bench about 100 feet high. We thought, silly Indians, what do you have to walk down to the ocean every day for? We just build our houses here. The science is the easy part about this, as it turns out. The hard part is culturally. We are neurologically challenged to deal with this. We evolved to worry about lions and tigers and bears running out in the path in front of us. And so we developed the fight or flight neurological system in response. We don't do well with 300 to 500 year recurrence interval events, or like climate change, long-term contextual change that we don't see every day. So we're like, this is perfect ground for us to be really stupid with the capital S. But we're smart enough to come up with the iPhone, right? So I mean, if we're that clever, we should be able to get the hell out of the way when the earthquake happens. But it's all about the psychology of believing that it'll happen and understanding what you have to do when it's done. Just by being aware of the valuable things we have in vulnerable places. And we just seem to put all our good things in bad places. And to think about that before it happens. It's too late to turn the app on and find out where the hell you have to go when the event happens. And getting people to prioritize something that's important but not urgent is like one of the hardest things. So that's why events like Japan and March 11th were so important and instructive, and it's like seize while the iron's hot. Talk to as many people then, because already people are fading. It's already leaving from people's minds.
I was going to ask about what the state of the art of monitoring is right now and how...
Monitoring for earthquakes?
Yeah.
If your chair moves, we're having one. I mean, there's instrumentation going on and all of that, but to me, and again, I come back to maybe the geography thing. This is not going to be solved by technology. The earthquake will be your warning. You don't need a siren. The earthquake is your warning. Get to high ground. They're not predictable, but I don't think everybody should sell their property in Seaside. I just think we need to learn how to live here like we know what we're doing. And it's not that hard. Earthquakes run to high ground. I mean, the shirt says it. We just need to believe it. And what was true in Japan was people who practiced and drilled and expected it to survive. So Cannon Beach contracting did some mapping. They had the state geologists come in, do some sophisticated mapping, get a good sense of where the inundations areas would be. They then are doing things like city council had a task, a committee looking at things. They have a preparedness committee. We also had a bad storm in 2007, and these folks are looking at things like shelters and how to boil water and feed people properly in the church and stuff like that. But the tsunami committee is doing things like, in addition to the state produced maps, they did walking maps where they actually walked routes. And on a new set of maps showed if you live here in this zone, this is the route that you should walk. Or these 3 routes that you could walk with times and that kind of thing like that. And encouraging people to do that and to walk. They have a safe house program where some people up on the hill are saying, if our house is still here, come here. We'll house as many people as we can. They're doing some caching where they get like a big shipping container and fill it up with blankets and power bars and stuff like that. And you put it up on the high ground, and you have to circulate stuff in and out of it. And maybe there'll even be some jobs doing community education on coastal hazards. It's kind of a big thing, adaptation planning, assessments, community risk assessments, hazard mapping, things like superimposing the like a census data onto the hazard maps and finding out, for example, where are the high concentrations of renter, single parent, low-income households. Because statistically, you know, that category of people are less prepared. They tend not to be as prepared or know what to do afterwards. So, where are those? Where are the elderly? Where are the people over 65? Where are those pockets? Can we do something? There's a thing called Map Your Neighborhood where Manzanita's doing this. They have block captains in a neighborhood. You might have 20 houses around your house, and they go around, and it's voluntary. It's a little bit Miss Nosy in some ways, but basically, look at the plat map, have a plat map of your neighborhood, and then each house you'd have a sense of what they had. What are their resources? Do they have a generator? You know, somebody, Mrs. Johnson over here is on a respirator and needs electricity. So if something bad happens, let's get those 2 together. And also just by walking around talking to your neighbors, we don't do that enough.
This is a really different question that you may or may not be able to answer, but I was wondering if there's some interesting oral history from Native people in the area of past events.
There are, and it's been pulled together, and it's really sketchy and thin, but it's essentially the story of the thunderbird and the whale up at the Hoh tribe, just up north in Washington, and really kind of interesting that were just sort of stories, but how the research that came together to tell about the 1900 tsunami, their current research identified that the last big one was in 1700. Not only that, it was at 9 p.m. January 26, 1700. Japan received for them a distant tsunami, no earthquake, but all of a sudden, bam, with a medium-sized tsunami that was measured by the insurance claims of the fishermen or the rice farmers that had bags of rice in the port. And the water came up and inundated some of them and ruined them, and the ones above that were okay. And so by looking at the insurance records in Japan in 1700, they kind of determined sort of wave height coming in at the port. And all kinds of other kind of scholarship, and then reversed it backwards to time zone and different calendar and all that kind of stuff. And the earthquake would have had to happen here at that point in January, 9 p.m. on the 26th of January in 1700, for them to have received it when they did. There are iconography about earthquakes and tsunamis, and certainly the recurring nature of these, that they're like a spirit that's here all the time. Just because we moved here, that spirit didn't go away, like we think. And also the Coos tribe in the southern part of the state, and certainly the Yurok tribe in Northern California were the ones that were used as the example of having their permanent settlement up on a bench by the estuary at about 100 feet. And but every day they'd walk down the bench and go down and make their living in the estuary, and they'd go back home. And early settlers thought they were stupid. And now we put the inundation maps in. Guess who wasn't so stupid?